Okay, sorry for this some network issues. I'm using the Wi-Fi at the cafe and Zoom has some issues, so I connected to my hotspot now. So make sure that mobile is charged. All right, so let's get back to the example we were discussing earlier. If you have these columns in your data where you have name, age, gender, so we already know that we have a couple of variables. Like if the variables are these are variables, so these variables have two types. We call them numerical and categorical. Once we have numerical, then we further read discrete and in the categorical, what we have is we have and ordinal. These are the variables that we have. Okay, so when the numerical, when we had to predict any of our continuous variable, what we have done is we have used regression algorithm. So regression algorithm, what do they do is they help you to predict numerical continuous variables if it's about salary, age, or anything. But what will happen if it's a categorical data? So when it comes to categorical data, regardless of whether it's nominal or ordinal, we have a different kinds of supervised learning that is known as the classification-based algorithm. So classification-based algorithm means those algorithms where you're still using the supervised learning, but the data itself is categorical instead of numerical. So we call them classification-based algorithm. So normally, when you look at this probability, it's is continuous. But if you wanted to convert this to whether a person will have yes or no, like problem in future, so what I'll do here is I'll just insert new column and here risk. And in the risk factor, what I can do is if this value is greater than 0.5, I so, so I can have this column now where what I'm doing is I'm just gonna see whether the person has high or low. And in this case, I can do one more thing, conditional formatting. So you will see that these are the people with this kind of uh, explanatory variable. You can predict the categorical data, whether it's going to be low, high, depending if you have more values like very high or anything. So that can predict for you. So now in such cases, when your variable, target variable is going to be uh, nominal or ordinal in that case. So you can use classification-based algorithms. For classification-based algorithm, we're not going to just use the very string values that you have here and here and here. What we do is we try to transform our data in the early stage. So for the gender column, what we do is we create another cell here, column here, and that column, we split this into male values and another one as female. So male values is going to be keeping the values if so what we do here is we kind of created split of the values of the gender column and we converted that to be male or female. So the values would be 1 or 0. You can make it empty or you can make it 0. Normally, if you want it, the null values of pandas does not identify it to be a null value, then it's better to call it 0 in this case. And also here, make it 0. You don't have the problem. So you get 1, it's male, so that's a possibility of 1 value, and that's low. So this is how you can convert the nominal value into ordinal value. Similarly, for the BP, you can also convert that. Let's say I want to convert this to ordinal. So I'm going to create a new column here. Blood pressure. Okay, and here, what I'm gonna do is Excel, and Excel things are a bit easy to do with, this is H2, right? So that's gonna be H2 with possible values of low, medium, high. With that of 1, 2, and 3. So we will apply this. Oh, we didn't use the very high. Okay. You know, we have very high. So in this case, what we did is we converted our BP value to make it now this and this. We will get rid of them later on when we drop the data. But at least we kind of created nominal data into more of categorical. Now this 1, 2, 3, 4 doesn't mean they're numbers. It's just categories that it represents. So 1 minute. Okay, so this is the data we were talking about. So now we already converted our nominal data into ordinal data. Now we're working in Excel, so you have the choice in the before the EDA if you want to work in the Excel if the data is already in Excel or CSV, but most of the time the data will be in the cloud or in a database. So you have to use their own technique how the ETL will be done, extract, transform, and loading for classification purposes. Otherwise, we have, once you load the data into pandas, we have a function in pandas, which is known as pd.get underscore dummies. We will study that and when we do the notebook next week on classification. that can convert the nominal data into ordinal data for you. So when I highlight this yellow, this job is done when it comes to classification because we have our data already come here. For BP, we came here. So it's easy. Now, if you're going to do the same thing with obesity and cholesterol, we can practice it a little more. So all we need is just get the formula and paste it here. But we need to change this to J to it and keep it opacity score O or something, ordinal data. And this one is now obsolete, so we can get rid of it. Similarly, for cholesterol, we can also do the same thing. We just create a new column, cholesterol for ordinal. And apply. Save. Start with K2. We don't know. So in this case, what happened is cholesterol data is obsolete as well. So now what happened here is the first thing is we tried to convert our data. So in the beginning, we have the data in a properly categorical and nominal data. So from that, we converted this gender. So maybe let's not do this. But instead, I'll do like this and this and this and this and this. So now what you have data left is all of the ordinal data. You can hide them as well. That's better because I'm gonna share this topic with you. So this is what you get, and that's your target variable, what you're gonna predict in terms of probabilities you want, or you want to get like low or high in that case. So this is the first thing. Now, when you know that when the columns that have something very much all nominal data and they're all like kind of unique values, the repetition is very less, so we usually drop that column, and we will do that as well when we look into our data, real data and plan in pandas. So this is it so far. Do you have any question how we get this data, how it works, or anything just for understanding how we convert the data? Because classification is very much looking at the categorical data to predict instead of numerical. It's not like prediction. Classification is not a prediction. It's just like classifying whether you're playing a game to predict if this is going to be a horse or a dog or a cat. So you play the game through different variables, different hints, and then later on you see whether you classify the animal to be a cat or a dog or something or a bird. Not like predicting it, but more like classifying it. So that is the idea behind here. So I'll just save this file and I can share that later in the group for just learning purposes. Okay, so now let me share this so I don't forget it. Now coming to our slides now. So we are at classification. Okay, it was your message. All right, so we are at the classification here. So we will start with that concept, okay, in the early stage. So classification is to classify if this is going to be like one category or the other category. You can say like a person, student is going to pass or fail. Are you going to have a class next week or not? Something where you have different categories, classes, possible answer, and you can classify them towards like more of like predicting categorical variable, which is your response variable instead of the numerical variable. Now in regression, you have seen that what does the regression line do? It's kind of create a trend line, and based on that best fit line, you can use it to project and predict future values for the variable. In the classification, it's also a line-based algorithm, but it's not going to predict the line in future, but it's kind of like a boundary line. Here, the word I will use boundary line. So if you look at the school or this college or university where you have gained some test and you have some grades. So now if the test scores are on your x-axis and your grades are on your y-axis, you have to see whether you belong to in the past category or group or class or you failed. So when you plot the data here and you see these different dots, so some of them are in the pass region like this one, some of them are in the failed region like this one. So what that means, how you create that kind of like a boundary to divide these different region in the data. Like if a student has 7 out of 10 in grade 6 or 7 and grade 6, something here, so how you know that this person is going to be pass or fail? So from the data you input for learning in the supervised learning for classification, the model gets the learning from the data itself. And what it does is it creates for you this boundary line. This boundary line is like, we call it like the cut. Where does the cut come? When the cut is there, the boundary line is there, it's easy to know the region, whether it's a pass region or a fail region. So the main idea for the model in the classification is to get this boundary so you can get two different classes, whether the data is shared earlier in Excel. So you can see whether this person is going to be in a risk high region or in a risk low region. So that's what the model is going to work on. Now, this is not that simple that you just draw a line and that it's just two boundaries. You have to look at different things, this cut, how the cut gets and how accurate is the cut. Then we also have performance metrics to work on about these cuts as well. So this type of algorithm where you get a line, straight line like this, and you get two boundaries out of it, is known as logistic regression of classification. So classification is done, can be done in multiple algorithms, like in regression, we have linear regression, nonlinear, multilinear, different kinds of regression, polynomial regression. They also have in industrially, you have bridge and lasso regression, but we don't necessarily teach that because first, we don't have enough hours, and second, it's required a bit of calculus to understand. And then most of the students come to these courses here are not like coming with solid understanding of calculus, so that will make it more complicated and longer to finish. So in the numerical data of supervised learning, it's not just linear regression. You have polynomial, multilinear we studied, and then we have lasso and ridge regression, which you can further study on yourself if you have time, or I can share with you some resources on. Now coming to the supervised learning and categorical data. So we have classification-based algorithm in which we have a logistic regression. So this is the logistic regression. And then we also will study in the next few weeks about in this course that you enrolled decision trees and random forests. So those two we will also study in the next couple of sessions. Now, today and hopefully in the next, today we will try if we can finish. I don't think so, but it's 73 slides and it's about a lot of concepts, new concepts here. So we will try to do the notes on understanding of this algorithm, this of the classification, specifically logistic, and then you also have to do a notebook on it that we have to perform. So maybe this will take 2 to 3 classes to sessions to finish the logistic regression. So now what usually happens that you see here in the, this is known as binary classification because you have only two different possible regions in that case, but it's not always the case. It could be having multi-binary classification or tertiary classification where you have multiple regions created. But in this simple example, you can have pass or fail, low or high, or something like that. So it's called binary classification. And we get two different classes. When you do binary classification, we get like this in this business domain knowledge, business knowledge, you can say is the course. This is like passing class region. This is a failed region, but in a real scenario, when you want to do it like a more systematic vocabulary for it, so this will be known as a positive class, and this would be known as a negative class. I will do this annotation so that who are watching the recording later on have an idea. This is a positive class. And this is the negative. But in this specific example, domain knowledge, we call them passing region and failing region, but we call it positive and negative in a more generic. Okay. Do you guys have any questions so far? Do you have any questions so far?
No question.
Okay. So what happens actually? So logistic regression. If you want to know like what is logistic regression, so I can write here like kind of a conceptual idea that time is used to create the boundary between two places. So it is called regression because of the line. Regression. But this line does not predict for you any of the future values, as this is part of the classification-based algorithms where the target variable is categorical in nature. So again, if you're watching the recording later on, you will be able to like take screenshot and then analyze this whole statement. So this is just like a brief description of what is logistic regression for you. So in that case, it will be helpful for you to understand. Now, when you look at the boundary is always in the form of a line. And we know that when there is a line, there is an equation, the equation that helps you to get the line. So there we need to study the equation itself for this line. So let's say the equation is already mentioned here for the line is 2x1 plus x2 minus 18. Now this is not a linear regression. Equation is just another equation of a line, not in the form of y equal to mx plus b. So you have x1, let's say this is your test x1, and x2 is, let's say, your base. if you transform that to this equation now, it becomes score. So what we do is every time, some people call it score, some people call it ranking. So for each equation, each data point, we write it in the score or the ranking format, which means that x1 is test. So your score will be calculated by multiplying 2 with your test variable, and then you add that with the points coming from the grades. Let's say if you were at this, if you want to calculate this region probability. So for this, for example, 5.5 and going to be 3. So that would be 2 times 5.5 plus 3 minus 18. So the score for this point will be 11 minus 15, which is minus 4. So for each data point, it calculates the score for it or rank with the rank for it. And then how do you know if this value for this data point based on -4 comes to the negative class or positive class? So for this, to know the decision, like the decision of each data point, each row, each observation, that whether it belongs to the positive class or negative class. So for this reason, we need to have a bit of domain knowledge of the data. So if I want to know in a data Excel data I was talking about, I'm not going to be a good person to know if a person has a low BP, medium obesity, and medium blood pressure, cholesterol to see if the probability or the risk factor is high. That is the doctor's job, because doctors and medical professionals are the person that decides prediction criteria. So that would be different in that case, this prediction. Now, in my case, because I'm doing something to do with academics and to do with assessments, and assessments mean that if there is a score, passing score of 450 or something, then I will get that with positive class, or if it's less than 50 is a failed class, a negative class. So in that case, what I did is I create this equation according to my to my knowledge. If the score is equal or greater to 0, I'll put it into exact, which is my positive class. If the score is going to negative or less than 0, I'll call it negative class, or I'll reject the class. So now, just because the domain knowledge that you have, you will be able to predict it. You will be able to predict this value. You need to know the domain knowledge, you know, whether the score is this much, so where class it will go, and the score of this. So now, if you know that for this data point, the score comes to -4, you see it here, and -4 comes less than 0, so that's why it's a rejected zone for it, negative class. So that's the whole reason calculation done before it. So now, if you know that equation of the line is this, similarly the score is this, so what is the score of student who got 7 in test and 6 in quiz? So would you be able to solve this question now? If what will be the score and where the person will lie if the test is 7 and the grades are 6? So what do you think? What will be the score? And which region will it belong to? Yeah,
Yeah, that's it. 2, I think.
yeah, 2.
7 times 2 plus 6.
Yeah, excellent. 20 minus 18 is 2. So if the score is 2, that means it's going to be in a positive class. So if you do 7 and 6, so we're talking about this data point somewhere here, and it's already in a positive class. It means the model has predicted it correctly. And if you have to do it manually, mathematically, it's turns out to be the same answer. So you can say yes, that is good prediction for the this value. This is how it works now. Normally, when you see here, this is the discrete and continuous debate. Yeah, yeah. Okay. Now, it depends. Now, previously I gave you example where you have risk column, where it's high or low. You also had that hard problem column where it's more like probability percentage of certainty. So it depends what the data is looking for. If you're looking at the discrete column data or a continuous column, that would be different in that case. We have a step function that helps you to get the prediction if the data is discrete. On the other hand, we have sigmoid function if the data is continuous, like you want to know probability based values, how much the probability that it would be in a positive region or a negative region. So at the end, when you do the projections, you will get this kind of predicted data where you have originally the data point belonged to positive class, but the model has predicted it to be negative class. You see here, it's red, so it was negative, but it means the boundary cut that happened here, it's not nicely done. So what the model could have done is if this curve, if you see here the decision tree, if this decision tree, not decision tree, sorry, this cut for the boundary, if it was happened something like this. So in that case, what you see is blue is predicted in blue, blue is predicted in blue, and blue is blue. Red is done this, red is done this, red is so now every model is 100% accurate, but it's just based on the learning, supervised learning it happens. It will create this cut for you, and then it will predict the values in those regions. So we know that this is originally a red dot, which means belong in a negative class, but it has been predicted in blue. Similarly, this one was actually passing score, but been predicted in the red region. So that means how many of them are correct. So this has predicted this correctly, but these two are not. So you can say 4 out of 6 have been corrected. That is predicted accurately. Similarly, if the data that you're doing is based on probability and percentages, so instead of that, you will see the percentage of it. So even though 60% likely it's going to be in blue, but it was originally red, and it was 40% likely to be positive. So it predicted a negative loss. So it also depends to know how the performance of the prediction is. So backend, you don't need to like do these things in your notebooks, but because I try to understand and explain the algorithm in the beginning. So the function that has been working on a discrete is called step function between 1 and 0, and the sigma that is working with continuous data is a sigmoid function where you have calculated by this thing come from you. The x is actually x is here the score that you calculated in the previous steps. So that is the sigmoid. So you already know that the score that you calculated previously for a question was, what was it, like 2 or something? So in that case, the sigmoid value would be 1 divided by 1 plus e to the power minus 2. And it would give you some values. I don't have a calculator now. So it will give you some value around 0.88 or something like that. Now, what does this 0.88 value means? This means that 88% likely that the data we have is in a blue region. And it's 88% likely spent is already a blue region. We have seen it. That is this data point where the score was 2. I think test was 7 and grades was 6 or something. For this data point where test is 7, grades is 6, score turned out to be 2 based on the equation of the boundary level. This 2 goes to the sigmoid function and tells you what is the likeliness of this to be in the positive class. And it turns out to be 88 for you. Why positive? Because the score is more than 0. So it's definitely going to be in positive class. The sigmoid value will be in the likeliness in a positive class, which is the blue class in this kind of slide. Any questions? Are you getting what's happening here? The first, it might not be that easy to digest, but when you go to do a notebook, it will be much easier because here I'm trying to explain the working of the algorithm like the statistically what happens at the back end. But when you do the coding, it's just very easy.
Okay. So next week we will do the coding.
Yeah, we will do a notebook on this. I mean, next week, hopefully, if all the students now, it's just you here, and all 4 are not here. So I hope they will be watching the video. And I cannot go in very too much details. Let's say I can go for like 30, 40 more minutes to explain the concepts. If it didn't, then I'm pretty sure they're gonna be asking me again. So I'm gonna be explaining it again quickly. So I don't want to like go in too much detail because this topic is new for every one of you. I didn't do this because of the time limitation in the previous courses. So it's kind of a bit new, so it needs time. But once you go to the notebook, it's going to be very easy to understand in that case. Now, when it comes to predictions, these are the predictions. Like this is the kind of a graph and a chart you will see that what is the most likeliness of each data point to be 30%, 50%, or 80% predictions. Now, when you look at the prediction for these persons, this is the scoring points that you have calculated. Then you applied the sigmoid. So sigmoid is represented by this symbol. Okay, so then you applied sigmoid of it. So the values of the prediction we had becomes the previous score that you applied sigmoid. Now, sigmoid, if you want to know like what's this omega, so I can write it here again. Sigmoid, the sigmoid that you have, if it's an x variable, is equal to 1 divided by 1 plus e to the power minus x. So once you have this to help you the score, you apply sigmoid on the score, that becomes your prediction score. So you'll get that from likeliness from 0.01 to 0.99 or maybe 1.00. So sigmoid values are always between 0. This is sigmoid. If it's a continuous. Otherwise, we use step function. It's display. And we not manually assign them. It's just model. If we look at the data and then use it. Correct. So this is how the predictions have been framed. That you can go now, after sigmoid value, what happens is what is the maximum likelihood? Now, maximum likelihood is not like really that you need to look at all. Okay, that's going to be important when you go to the performance metrics to understand whether the performance is good, like the majority of data has been predicted correctly in a correct region or not. Then in that case, you can do that, but you can just multiply odd sigmoid values and then you can give it. Problem with it is that sigmoid values are between 0 and 1. And if its values is less than 1, and you in decimals and you multiply them, the values go smaller and smaller. Like 0.6 times, 0.2 times, 0.1 times, 0.7, even though all the values are much higher than 0.1, but the end result becomes smaller and smaller. So that's a problem, mathematical problem with percentage, with multiplication, that if you keep on multiplying the sigmoid values here, the end result of the likelihood becomes smaller and smaller. The other hand, if you have this, then that's okay because it's 0.3, but even though the 4 data points predictions is not 0.3, it's more of could be the average or something to know the maximum likelihood if the cut was like this or the cut was like this, doesn't matter. So what we do in this case, we use this mathematical concept that in these cases where you are dealing with decimal numbers less than 1, we have a rule that you're not going to product them, you're going to be adding them together. So instead of multiplying them, how do you add? So do you know mathematically how, if you have this multiplication, you want to convert that to addition, what function we're going to use of mathematics that you can convert a product to sum? Do you know the function that you can use to convert product into addition?
I don't know.
Yes, it's the log function. So what does the log do? It's a bit of mathematics because it's a statistic part of the algorithm. So you just need to rely on this. Let's say if you have two products, M and N, if they are in multiplication and you want to convert it to addition, so what you do is you apply log on it, log action. And log is M times N. What does the log do is the log has a rule when it's multiplication, it will create log of M plus log of N.
Yeah, I remember now from my college.
Yes,
Yeah, I remember now.
yeah, that's a problem with algorithm is you need to either you don't need to know that, and then you can just go to the notebook directly. But the problem is in the notebook, some things will come up, and you will ask me how does this work, and then I have to re-explain the whole concept back end. So it's better to do it first, understanding, and then the notebook. So this is how you converted a product to sum by applying natural log or log on it. And this log of M will have some value plus log of M will have some value. But the story doesn't finish here. That's the problem with classifications, understanding. There's another concept called cross entropy. Cross entropy. You know what is entropy? Like, have you heard about this word entropy?
Yeah, I've heard of it, but I forgot already.
It's entropy usually used in a scenario where there is, like for example, if in a country there is some law and order situation, like something misorganizing or something lack of order, something like where there is some ambiguity, there's something not right is happening, so entropy is happening. Now, what is entropy in this case is this is the error function of the logistic regression. You remember the error function of linear regression, we looked at the mean squared error and absolute square error, and then we study the learning curve. Remember? Similarly, error function of the logistic regression is cross entropy. What is cross entropy? It is the lack of order or disorganization in the prediction. So how many of them are not being done correctly or well? So less it is cross entropy is error function. So it means if the cross entropy is low, it means it's good performance. If the cross entropy is high value, it's bad performance because the error is more, it's a problem. If the error is low, it's good. So this is the error function. So cross entropy means less entropy is better. So how do you do that? This is the product of all the sigmoid values, the prediction values. Then you applied the natural log on it. But when you did the natural log on here to convert the product into sum, what we see is the values comes as negative values. Now we cannot have, because error is a mistake, it is always a positive. It cannot go negative error. So what we do is, in order to get rid of this negativity, when you convert from product to sum, we do natural log on it. So previously, if I have written something like this, if I have M and N as a product and I apply log on it previously, what I get was I got log of M plus log of N. But that means this will give me negative and this will be give me negative values. So instead of that, I'm going to do negative log of M, have my errors always positive. So this, instead, so you will get the values it's this for each data point. So this is the error in the first one, error in the second, error in the third, error in the fourth. You add them together, you get a 4.8. The other hand, if you do the same thing, error in one, error in two, error in three, error in four, the total error comes to be 1.2. Now this means the cross entropy of the second is better. This one is better than this one. So if you look back, these ones. So this is obviously good because you have two positive, both of them predicted in positive. You have two negative, both of them predicted in negative. On the other hand, you have error because this is positive class predicted in red class. This was originally red, but predicted in the blue class. That means there's already some errors. That's why the cross entropy is too high in that one. And this is 1.2. So it means this model of predictions is much better compared to this model. That is the job of a cross entropy, to make sure that calculates how much is the error in each prediction and it can help. So now if you have to summarize how we reached cross entropy, I'm gonna write here chart. So we have boundary line created by the model, boundary lines with some equation. Okay, that's our first one. And then secondly, based on line equation, we calculated score. Based on score X, we calculated sigmoid value. Based on sigmoid values, we got negative log product of sigmoids and sigmoid value. Then after negative log, we added on the error in each point. Finally, we calculated the cross entropy. So this is how we have used different steps from the initial stage to reach the error function is by going through these steps. So we reach the cross entropy, and cross entropy came from here and here 4.8 because I just show you there was not good prediction here, but here it was more accurate prediction. So entropy means the error is lower in this. And then we have some functions. So whatever we've done, it's usually done through equations. formula. So if y is 1, it means the blue class, so the predicted y hat will be from the probability of the blue class, and that is just negative log of it. It's a red, so it will be 1 because probability of blue we know, and total probability is 1, so we will just subtract 1 minus probability of blue, which is 1 minus y hat for the red class. So the total error would be 1 minus y natural log of 1 minus y, and then for the blue class is just ln of y times y. So we will be looking at it. You're not going to use them because this is already written in sklearn library, but this is like the error function that you have in the model for cross entropy. Error function and cross entropy is same thing because cross entropy is the error function for logistic regression. So again, to go through it, classification, you have to get the boundary tree, as I mentioned here. You need to get the boundary line, some equations. This boundary line comes with, let's say, this equation, step 1. Then based on this line, we calculate the score. That is our step 2. We calculate the score. Then based on score, we calculate our sigmoid values. You know, the likelihood of the data point, if the score in this case is greater than 0, it will be the blue class, yes region. So this sigmoid will be the likeliness of the data point to be in the blue class. So we calculate the sigmoid values. This is like summary of it. Then we try to do the maximum likelihood. So we get a product of values that we had. And it turned out we see that mathematically there is a constraint there. So we applied the natural log on the product, but that turns out to be negative value. So we did negative log of the product value. So we got the errors for each data point. Then we added all the points to gather errors. We got cross entropy. Then we see the check the cross entropy, which one is good and which one is bad. So this is the things. Now I will write some things here, just in case you want to read more about it. So the criteria that you have, which I mentioned I think already. Decision monitoring is based on the domain knowledge of the data. So the person will get better idea how to play the scoring 0, greater 0, less than 0, where which region it will belong to. Similarly, in a credit card fraud detection, they have their own health sector habits, their own criteria, as I mentioned earlier. And if you want to make the model more complex, so like model complexity, usually leads to more overfitting. This like a sort of statement I remember from supervised learning. So you don't need to make it more complex, the more complex that it becomes starting to your overfitting if you remember fitting to fit. Again, this is supervised learning, so you have to remember all the points of supervised learning in this case to not miss anything. So this is what we have done so far. We reached the error function cross entropy. The next thing is, I think, because when you reach here, the cross entropy error function, then we need to know how to evaluate our models. So I will go to the evaluation later on once we start the notebook and do some stuff like to do some predictions and get boundary line, predict whether it's true, false, like positive region, negative region. And once we have some predictions and we have some cross entropy, then we can do the evaluation. We have confusion matrix, accuracy, precision, recall, Alphonse score. There's a lot of different performance metrics here, like R2 scores, residuals, and CV, and we've a lot of others there in the adjusted algorithm, in the linear regression. So here we also have this matrix. Now I'm gonna because of the guys they didn't show up today, I'm gonna stop it here, and hopefully they watch the video. I will upload it, and then they come back next week. So I'll begin the notebook. And once we do the notebook, we'll get more clarity of these concepts. And after that, we will move towards the model the performance matrix. I will just first explain what they are, and then we will also plug on the same notebook to know if the predictions are good or bad. Now, do you have any questions? Any question that you may have?
Yeah, no, not on this topic now,
Yeah.
but just curious, but on the notebook, are we going to, what libraries are we going to use? Are we going to
Same
use
library,
new
we have
libraries?
the same pandas, NumPy for, now the thing is with, when I have the notebooks for this part of the data, I don't do EDA here because, you know, the EDA is a long process that takes days as well. So I'll just give you data that's already defined in a good shape, and we can
Ah.
just go with sklearn library and then apply our classification algorithm, use the logistic regression, and after that, a decision tree, and after that, random forest. And then if we have some time, we can also go to a bit one or two of unsupervised algorithm as well. So that's my plan for these total 10 sessions that I have with you.
Okay,
All right, so I'll just
Yeah.
pre-process the video and upload it. Then just watch it. And if you have questions, you can always have the WhatsApp group. Then I will going to do the notebook next week. Hopefully the guy, one person have an accident, not major, but his car was a little damaged, and then Ronald said he's busy with shift today. So, and I don't know about Anna and Steven, so hopefully they will also watch the recording, and all of them are present when I do the notebook. So until then, take care, and
Okay.
let me know if you have any question in the WhatsApp.
okay, thank you.
All right,
Take
bye-bye.
care. Bye.